Welcome back to Principles of Electronics, lesson number 4. Today we're going to be talking about Ohm's Law and schematics and how they relate. We learned in lesson 3 about resistors, and now we're going to kind of draw some stuff from lesson 3 and see how you can apply it here in lesson 4. Now, Ohm's Law. Ohm's Law is a very important rule. It's a very important law. It is used widely in the electronics industry. You use it probably almost every circuit that you design. Up to this point, we've talked about voltage. We've talked about current. And we've talked about resistance. And we've given examples of all of them. Now, how do they relate? Well, they relate using Ohm's Law. Ohm's Law is the voltage is equal to the current times the resistance. Now, let's unpack this a little bit further. In a circuit, let's say we have a battery that's supplying our voltage. That's going to remain constant. 9-volt battery, AA, AAA, 1.5, whatever it might be, 12-volt, it's going to remain constant. Sure, it might go down over time, but for the most part, it's going to remain constant. So voltage really doesn't change. How we can manipulate our circuit, our current, precisely is through resistance. For example, in order for this equation to work, if resistance goes up, then current has to go down to maintain this equation. If resistance goes down, then current has to go up, again, to maintain this equality. This is how then we can determine what resistance we need to make sure we don't apply too much current to our circuit like we talked about in lesson number 3. So, how do we do that? Well, let's jump over to schematics. I'm going to introduce a couple symbols here that I haven't done so far. We've talked about batteries. We've talked about resistors. So the symbol for a battery looks something like this. And depending on cells and maybe whatever else it could have, it's alternating lines. That's our battery. One side is plus, one side is negative. And then our symbol for resistor is just kind of that squiggly line. This is a very basic, it doesn't get any easier than this, circuit schematic. Notice it's a schematic, not a diagram. In the diagram, I actually drew the battery and drew the resistor. Also in here, I don't have the light, which I had in lesson 3, but we're not going to use that right now. That'll be in the next lesson. But here's our battery, and here's our resistor. So how does this relate? How does Ohm's Law over here relate to this very simple schematic? Well, our battery is our voltage, and our resistance here, this value, whatever it might be, is our R. We can determine what our current is then using Ohm's Law. If we manipulate Ohm's Law, and let's say we know our R and we know our V, we can figure out our I, which is the voltage divided by the resistance. So let's just make some real easy terms here. Let's say our voltage, and this is just hypothetical, I'm just using easy numbers. Let's say our voltage is 10 volts. And we're going to use a resistance that's just simply a 10 ohm. So if we plug these values in, now we have 10 volts divided by 10 ohms, we get 1 amp. Now that's an awful lot, and these values aren't real, probably real life, but it's just to show you the relationship. Now, what happens if we up our resistance to 20 volts. I'm sorry, 20 ohms. If we go to 20 ohms, now my current is 10 divided by 20, which gives me 0.5 amps. So notice when I increased my resistance, my current decreased. Now, why is this important? This is important because very rarely do you have a circuit just like this. You have other things in here, a light, LED, which is going to be our next lesson. And we have to limit the current that goes through, say, that LED. So we have to adjust our R to make sure we have the proper current going through that component. Again, all of that falls on the designer, which is us. So, recap. Ohm's Law, vitally important to use basically on a daily basis. I use Ohm's Law almost every day. Schematic is our representation, our graphical representation. It's not a diagram, it's a graphical representation with our symbols for our components that we're using. This here also is just wire attaching them together. And this representation, this schematic, is how we can then go in and analyze the circuit using Ohm's Law, so you can see how they relate back and forth. All right, if you have any questions, please leave a comment. And as always, please subscribe to Spiderweb Education.